The effect of intermittent access to cocaine with and without alcohol use on cocaine-seeking and glutamate levels in the nucleus accumbens in rats. Consumption of cocaine and alcohol is one of the most common combinations of polysubstance use. Alcohol enhances the high of cocaine while facilitating the come down from the drug. The co-use of the substances inflicts greater harm onto the body compared to ingesting either substance individually. Existing research surrounding cocaine use largely focuses on the effects of the drug in isolation from other substances. However, it has been found that using cocaine in conjunction with alcohol differentially affects the brain compared to using cocaine alone. Polysubstance use of cocaine and alcohol has been shown to increase cocaine consumption and cocaine-seeking behavior in rats. The combination of the two drugs dysregulates basal glutamate levels in the nucleus accumbens core, which is associated with relapse of cocaine-seeking behaviors. Intermittent access to drugs rapidly produces addiction by increasing sensitization to the drug reward, and most similarly resembles the pattern of drug use in human addiction. Despite this, there is limited research into the effect of intermittent exposure to cocaine with concurrent alcohol use on the brain and addiction-related behavior. Past research has found that rats that access cocaine under a continuous reinforcement schedule, in addition to alcohol, showed lower basal glutamate levels in the nucleus accumbens core before and during a cocaine-primed reinstatement test in comparison to rats that only accessed continuously reinforced cocaine. Polysubstance-using rats also did not exhibit an increase in glutamate levels in the nucleus accumbens core after cocaine administration, whereas the rats that only consume cocaine do. Therefore, the current study aims to investigate how intermittent access to cocaine influences cocaine-seeking behavior and basal glutamate levels in the nucleus accumbens core in rats that co-use cocaine and alcohol compared to rats that only access cocaine. It is hypothesized that rats with intermittent access to cocaine and alcohol will demonstrate increased cocaine-seeking behavior and show greater dysregulation of basal glutamate levels in the nucleus accumbens core in the negative direction compared to rats with intermittent access to only cocaine. The current study will employ a between-subjects design using male Sprague Dawley rats that will be randomly allocated to either the experimental or control condition. The experimental group will receive intermittent access to cocaine and alcohol, and the control group will receive intermittent access to cocaine and water. The independent variable is a type of drink received, which is alcohol or water. The dependent variables are basal glutamate levels in the nucleus accumbens core before and during the cocaine-primed reinstatement test, and cocaine seeking, which will be operationalized by the number of lever presses during the cocaine-primed reinstatement test compared to the first day of extinction. The procedure will involve all rats undergoing surgery to implant a catheter into the jugular vein and a guide cannula above the nucleus accumbens core for cocaine self-administration. After 3 weeks of recovery, the rats will undergo sessions of cocaine self-administration. From 9 a.m. to 12 p.m. every day for 12 days, rats will be removed from their home cage and placed in an operant chamber with 2 levers, an active and inactive lever. When pressed, the inactive lever will result in no outcome, while the active lever, when pressed, will deliver an intravenous dose of cocaine. Cocaine will only be available during the first 10 minutes of each half hour of the 3-hour session. Immediately after each session, rats will be returned to their home cage with 6 hours of free access to their respective drink, so alcohol or just water. After 12 days of cocaine self-administration sessions, the rats will undergo 12 days of extinction. So from 9 a.m. to 12 p.m. every day for 12 days, the rats will be removed from their home cage and placed in the operant chamber. The levers will be available, but they won't result in any outcome if pressed. And from this point onwards, only water will be available to rats in their home cage. After 12 days of extinction, the rats will undergo microdialysis surgery and have probes implanted so that glutamate levels in their nucleus accumbens core can be measured. The day after the microdialysis surgery, the rats will undergo a cocaine primed reinstatement test. So the rats will be placed in the operant chamber and baseline glutamate levels will be collected every 10 minutes. The rats will be given a dose of cocaine and any lever presses will be recorded. The rats will stay in the chamber for 100 minutes during the cocaine primed reinstatement test. Figure 1 illustrates the expected average number of lever presses for each condition. There is a significant difference between the experimental and control conditions at the reinstatement test, with the rats who received cocaine and alcohol showing increased cocaine seeking. This reflects the greater chance of relapse with polysubstance, cocaine, and alcohol use. Figure 2 illustrates the expected average basal levels of glutamate in the nucleus accumbens core. The rats in the experimental condition who received cocaine and alcohol have significantly lower basal glutamate levels compared to the rats in the control condition who only received cocaine. The rats in the experimental condition also do not show an increase in glutamate after cocaine administration, while the rats who only received cocaine do. There is an expected difference in cocaine-seeking behavior and basal glutamate levels in the nucleus accumbens core between rats that intermittently access cocaine with additional access to alcohol compared to rats that don't access an additional substance. The results from the study will provide insight into the neurobiology of polysubstance alcohol and cocaine use, which has implications in guiding the development of new medications to treat and manage addiction. Understanding how glutamate levels in the nucleus accumbens core are affected by polysubstance cocaine and alcohol use is a critical step towards being able to investigate ways in which homeostatic glutamate levels can be restored to reduce the likelihood of relapse. Furthermore, employing an intermittent schedule of cocaine access will also better model the pattern of drug use of humans in animal studies so that treatments developed can translate effectively to humans.